Hello, it is me again. I am back to work on my game engine. Yesterday I had a 4-hour stream in the evening that didn't go particularly well. I was starting work on a simple 2D renderer using the framework for creating renderers that I've been designing. And I think I wound up chasing my own tail for a little bit because I didn't define what I needed very well before I started. So I took some time this morning to kind of consider the position, and so I made some mock-ups of GLSL files that I want to work, and this has kind of highlighted a few features that I need to get in the GLSL parser before I can get there. So for starters, one of the big things I have in my engine is the ability to include other GLSL files. And my intention is to use this to make shaders that are make it possible to write material shaders that are compatible with a wide variety of renderers. And this is a mock-up of what that might look like. So all GLSL files I plan to have include enterprise.glsl, which is basically just like I'll pull it up from the engine. Basically just a header that includes the stuff that every shader needs. So every shader needs the camera information, basically, and every shader needs the model matrix, and there, by extension, the model view and model view projection matrix. And eventually, I think I'll need to do a universal position. So having a predefined vertex attribute for position, but for the moment I don't have that set up. And so you just include that, and then it includes the things that you need. And I think the plan is that, like in this example here, you can in a header specify which mode or which part of the shader program to include in. So for example, invec EP position, I say ifdef EP vertex. This is defined by the GLSL parser when we're doing the vertex shader. This means that this line will only appear on the vertex shader, not on the fragment shader. And you can do that for anything. So going back to enterprise, I'll undo that change and close that out. With concerns to doing a batch 2D renderer or really just any batch renderer where you want to batch together textures, you kind of need a system to be able to bind as many textures as possible for a single draw call. And then you need to have a vertex attribute that tells the shader which texture in all the bound textures, which texture ID you're going to be using. And in order to do this in a way that supports both batch and non-batch rendering, I kind of came up with a scheme that looks like this. So I'm imagining, like, in the final version of the engine, this will be a GLSL header that comes with the library, or with the engine library. And so let's go over what it contains. So this is something you would include at the top of every file. So it would be like this, except for maybe in angle brackets because it's part of the engine library. The first thing would be a pragma option statement, which pragma option works in my engine right now, but it doesn't work in include files. So I would need to actually do some significant overhauls to my GLSL parser to, whenever you go to include, to not just load the include file, but to also parse it for pragma option statements. So I'm not going to do that right now. But the idea is that it would specify that we're going to make two versions of the shader that you included the header in. One that's just the regular plain text shader, and one that supports batching. And then we use ifdefs to handle this. The way that pragma option works is that when you specify a list of options, and you can do as many options as you want, the compiler will compile one version for each option, and this whole line will be replaced with define whatever the key is. So like EP batched instead. And so when you're working with multiple versions, you can do if def batched to say, okay, this code exists in this variant of the shader, which is pretty similar to how like Unity does it with its shader stuff, except for this is GLSL. So I'm thinking that when I go to write a header for a rendering system, I want to have this part like taken care of inside of it, so you don't have to like do a boilerplate code here. And then within the rest of the header, we define the stuff that needs to be available in the rest of the shader. And for the sake of batched stuff, I kind of planned out to make sure that this actually would work in the end game. Basically, I provide a couple of helper functions, technically function-like macros, that you would use for declaring samplers and use for sampling the samplers. And then, depending on whether or not you're in the batched version of the shader, it will either do the texture handling, where it'll do it'll automatically handle pulling from the right texture slot when it's bound in a whole list of textures, or if in the non-batch version, it would just be a regular sampler that doesn't have all that batching logic. And then within the shader itself, your workload is kind of simplified, but you do have to use a couple of macros to be compatible with the system. So basically, first step would be just to include the header for the system. In this case, it's still a mock-up. Then you would use, instead of going uniform sampler 2D to declare your sampler 2D uniform, you would use the helper macro, because this will either expand into uniform sampler 2D text or nothing, depending on whether you are batching this or not. I say or nothing, but it would actually expand into something that's not a sampler. We'll come back to that later. And then within each of these headers, if you're in the batchable version, it'll automatically include the vertex attribute needed to specify which is which. You would need to have like a macro helper to either pass the sampler ID or the sampler 2D, depending on whether you are in the batched or unbatched version. So in the batched version, this would expand into setting text underscore out equal to text, because in that situation, text is actually a vertex attribute, not a uniform sampler, and it needs to get passed to this location. And then on this one, you would use EP texture instead of regular texture. And what it would do is it would either just call texture with the sampler 2D and the UV, or it'll do the once removed lookup of the texture within the sampler 2D array. So I think this is kind of the goal that I'm looking for. One of the big advantages of this is that it's not much work to support batching, and any system that wants to batch can do so. It just needs to turn on the batching option when they're binding the shaders. But yeah, there's a couple of things that I need in order for this to work. The first, as I mentioned earlier, is that I would need to get Pragma option to work in include files, and that's going to require a significant amount of time, so I'm not going to bother with that at the moment. The other would be that I need to have EP position, this guy, this be a predefined vertex input, so you don't have to like specify it up here. For the moment, those two things are not a priority. What I'm going to do is instead I'm going to just get the batch renderer working where I have everything defined in a predefined GLSL file, and basically this shader file will just be used for everything that the renderer does. The other stuff will kind of depend on bunch of work that I'm not ready to put in quite yet, and I just want to get something displaying on the screen using the ECS system. So for now, basically, we got vertex attributes, position, UV, and a flat int text ID. So that should be in text ID. That text ID is just passed out to the fragment shader to be used in the lookup for the sampler 2D stuff up here. And I'm just going to try and get that to work today. And then after that's done, I may go into material systems and the other stuff I mentioned earlier, or I might just start going right into something like text rendering, so that way I can get a framework together for building an editor. But for the moment, let's go ahead and get this going. I'm going to need to do some recap of some of the code I wrote yesterday. Pick up here, and I left that note for my bookmark. So I think most of the other stuff in the system, the renderer 2D system, is fine. So the way that we store components, sprite components, is good. The way that we add them and delete them, keeping everything in a nice contiguous block of memory for iteration. And in scene draw, we kind of have to probably start over here. Let's see what we got. So the first thing I did is I allocated a block of memory using allocate, just so that it's a fast allocation, and it can be a variable length. So basically, I just wanted to have an array of vertices that I can construct in this little contiguous array and then push it all at once to the GPU. So actually I think that's good. Num of components means the maximum number of components, but right now we're not doing any culling, so that's fine. We needed to have texture handles for all of the textures that we are going to bind. We'll do up to a maximum of 16. And then number of used text slots for counting how many of these we filled up. All right. Graphics set model matrix, we needed to set a unity matrix or a identity matrix, so that way we can transform all of the models on the all the vertices on the CPU, and then you can still use in the shader times MVP or MVP times in order to get the correct position. And that should work both in the batched and non-batched versions, which is why I do it this way. And then we are iterating through all of the components that we have. So this is where we start. So we need to go through every single vertex that we need to send to the GPU. So for every component, every quad, there's going to be 4. And that's going to be determined by index in clockwise order, or counterclockwise order, starting at the lower left. So we've got I times 4, so we'll get every 4th one, 4 plus 1, 4 plus 2, 4 plus 3, so on. So on the lower left-hand corner, we need to get the entity position and then offset it by a certain amount. So if we've got 4 vertices, the center of the entity is going to be in the middle of it, of the 4 entities. So if we make this whole thing 1 unit by 1 unit wide in like world space, I think that would be best, because then you can set the scale of the entity, and then the sprite will just be that same number of units wide or tall. So we need to rethink how we're doing this. So we do need to get the view projection matrix and multiply. Actually, we just need to get the view matrix, right? Because if we do view projection matrix here, then we will be already in camera space. Or sorry, not in camera space, in clip space. Which actually might be what we want. Because then the model matrix here could literally be an identity matrix. But that doesn't work well with the way that I've got the model working. So the way that the graphics API works right now is that you push inside a camera, that preps or sets the view and projection matrices, and then those automatically get pushed into, going back to enterprise.glsl, those get automatically pushed into the per camera uniform buffer. And then when you go to set the model matrix, that automatically sets the MV and MVP. So I think I'll leave the camera transformation to be done on the GPU still. So this actually needs to be slightly different. This needs to be Well, we actually don't need this at all, now that I'm thinking about it. What we need to do is we need to get the entity position in model space and multiply it by the quote-unquote model matrix. So this whole helper function that I threw in can just go away. I'm not exactly clear on why I thought it was a good idea in the first place, to be honest. I don't think I was thinking very clearly yesterday. So that goes away, and instead we need to come up with the model matrix to use here, and then come up with the vertex in model space by offsetting from entity position and multiplying by that. So let me go back to h, and then I want to get, that's the wrong h. I want to get the view projection getter that I threw in yesterday, and just delete that, don't need it. And we'll go to here and get that out to me. Cool. That's already looking better. And let's head back to the renderer, pick up here. So we're going to be setting these verts. We're going to set them to some model matrix times the position of each vertex. So what's the model matrix going to look like? For it's going to be taking the entity position. I guess it's just a translate. No, we do need to do a scale. So what we'll do is we'll do GLM. I think we can just do translate. Then we do GLM mat4 2.0, gives the identity matrix, and then we do a vector of where we need it to go, and that's going to be get an entity position. Except for I don't need the .1. I just need the vec3 instead of a vec4. So now we've got a matrix that will translate whatever you multiply it against to the world position of the entity. We need to consider rotation and scaling now. Now, from what I understand, these GLM helper functions will go, you do left to right if you were to nest these. So if I wanted to apply a scale first, I would do GLM scale, and then within GLM scale provide the translation matrix, and so on. I'm still kind of new to GLM, so I'm a little rusty on, or not rusty, but new to a lot of these details, the proper way of using it. So if we were to use rotate, we would then provide a quaternion and a vec3. You can also provide a matrix for the rotation. The quaternion is something that we can get from the entity. So it's in manager, get an entity rotation, components i.id, and then the right would be the rotates a quaternion from a. Oh, this is the wrong method. It's not actually. It's trying to rotate a point, not get you a rotation matrix. Isn't there a rotate? Oh, you know what I think it is? I think it's that you just do a cast, GLM cast. I don't know, we'll type it out and see if it works. So it would be GLM mat for cast, and then we provide the quaternion. So that would be scene manager, get entity rotation, components i.id, and that gives us a rotation matrix. So actually, I would take and plug that in here. No, I wouldn't. I would plug that. I would do a right to left multiplication. So we would apply the rotation, and then we would apply the translation. Okay. And then do a similar thing for scale. But instead of doing a cast, it would be I think it would just be straight multiplication, right? Or no, we would use the GLM scale. That's right. And with GLM scale, we tell it the scale that we want. So we provide the matrix, and then we provide the scale factor. So actually we would wrap the rotation matrix with scale. And then the second parameter would be the scale from scene manager. Get entity scale. Okay, let's make sure that let's do a quick gut check. So it's with when you nest these, it's it's left to right. So we scale first using the entity scale. We then rotate using the quaternion rotation in the entity, and then we translate through multiplication there. All right, I think I got that right, but we'll see. So anyway, we got the in position. We're going to need to do for all of these the model matrix times some point. So GLM vec3 for all of these, and we're going to do these in counterclockwise order. So the first one's going to be negative 0.5, negative 0.5, and then 0.0 for the XYZ. Does that add up? It doesn't quite, because I need to have 1.0 at the end to make this a vec4. And then when we go to use it, we extract the vec3 out of it, which model map is map4. I'm a little confused why it's not asking me to convert here. I'm going to assume that there's an implicit conversion happening, but I seem to recall having to explicitly convert something yesterday for GLM. So yeah, not sure. But we will copy this out, and for these other rows, we'll use it as a base. First, we move positive on the x-axis, then we move positive on the y-axis, and we move negative on the x-axis, and stay positive on the y-axis. Yeah, and so this will give us all 4 corners. First scaled by the entity scale, then rotated using the entity's orientation, and then translated using its position. That seems right. And now we gotta set the UVs, which is just a setting operation. Verts dot in UV equals components I dot UVs. No transformations needed there. And then we need the index, so that's where this logic was. This is what this logic was supposed to do, but I don't think it did a very good job, so we'll just start it over. So what we need to do is we need to load up the texture if it's not already loaded, and then bind it. I'm thinking that the loading of the texture should come down to when we deserialize and delete entities. I may have already done that. So these are the UV coordinates being loaded from the YAML, and texture filter in MIP mode. YAML and path as string. So I do actually do call a load texture when we go to load the entity. So the texture is already loaded, we just need to select and bind it. So presently we have a limit on how many textures we can do at once, and that is 16. Just because for whatever reason on the macOS implementation of OpenGL, you're restricted to having 16 sampler 2Ds in an array. And we got the slots here. So all of this should depend on whether we have used all of the available slots, because if we need to bind an additional slot or bind an additional texture to a slot and we don't have any slots left, then we just need to flush and dry out the stuff that we already have and then come back. But for the moment, I'm going to just not include that check. I'm going to assume that we have enough room for a texture slot. So what we do is we do for size t, j equals 0, j is less than none of used text slots, j++. We're going to iterate through the text slots to see whether the texture has already been bound to a slot, and if it hasn't, we will bind it to the next slot. So we'll do if components at I dot text equals the text slot at j, then we've already got something bound. and so on. And we can use this slot. So we'll do verts I times 4 dot text ID equals components I dot text. Well, actually, it would be equals j. We're passing it the index into the sampler 2D array. So that would be the index that we pass. And we gotta do this for each of the four vertices. And I'm realizing now that I didn't do that correctly up here, so I need to go back and fix that. I times 4, plus 1, plus 2, plus 3. Okay. And I need a way to check whether we have exhausted the list. So what I'm going to do is I'm going to do size tj equals 0 outside of the for loop. And then we'll do check if j equals number of used text slots of. Then we will know that we need to bind the texture onto the next text slot. So it would be text slot j equals graphics bind texture, I believe. No, that's not right. We would set it equal to components I.text. And then we need to bind it. I'm trying to remember what I've overlooked here, but I'm pretty sure I've overlooked something. So when we've put the ID in the slot, we actually need to invoke bind on the index. Right, so that's what we do next. So presently, I don't have like an API that will take texture slots as the name and then take the index as the index into the array. So literally just I just bind it to texture slots, square bracket 0 square bracket as a string. So for now I'm just gonna have to do a switch statement. So switch on j. So whichever element j is, we assign to that index. So it'll be graphics bind texture. We'll need the texture handle, which is going to be text slot j now, and the uniform name, which is going to be texture slots 0. And voila, there it is, it's bound. And then we need a rapid setting case statement. So case 0, break. And then do this for the other 15 cases. Oops. Okay, and then name these as well. Oops. And then after this is done, we've got all of the vertices that we're going to use will have all the data we need. We'll have the position, the UV, and the texture slot, and the texture slot will be bound. So at this point we can draw, so we do graphics set vertex data, we get vertex ray handle, pointer to the verts, and we're going from 0 to the number of components minus 1. So that looks good. Then we do draw triangles. The number of elements is 6 times the number of quads, because there's 1, 2, 3, 4, 5, 6 indices in the index buffer. And then the last thing we got to do we need to unbind the textures? I guess not. I'm trying to remember how I implemented binding. I'm pretty sure binding would automatically handle using the actual number of text slots. So within, depending on the machine you're working on, you may have the ability to bind more or fewer textures. And I believe I handle this automatically. Hang on a second, I hear somebody knocking at my door. Sorry, I had to go check on that. Anyway, I believe that what it does is it just goes through all the texture slots from the beginning to the end every frame. So let's go to pre-draw in graphics. Memset is texture slot, use this draw 0. Yeah, so every frame we reset the texture slots, so we don't have to like call the reciprocal unbind after we bound. So, and that was the beeper telling me I got to turn over my laundry. I'll see if I can wrap this up real quick before I have to go do that. Okay. I just noticed a compiler warning here indicating that we have too big of a stack. Yeah, I guess we do. This warning comes from the way that we set up the index initialization buffer. So we make a stack array of 6 times the number of quads, and we initialize it with all of the variables or all the values that we need for any given number of quads. So 0, 1, 2, 2, 3, 4, or 0, 1, 2, 0, 1, 2, 2, 3, 0, and then 4, 5, 6, 6, 7, 4, and so on, going in that circle pattern around every quad. The warning comes from the fact that this is all being allocated on the stack, and there's a realistic chance that the memory would exceed some limits on some platforms. So this one, let's go ahead and do a malloc and replace the stack allocation. So we'll do an unsigned int pointer called index init buffer, same as the name that we had below, and then we'll set it equal to malloc Actually, let's do the C++ way, and we'll do new index init, or new unsigned int array, and we'll do it 6 times max sprites. I believe that's how you declare it. Okay. Yeah, and so now we've got that allocated on the heap instead of on the stack, which is slower, but we don't call this at the beginning of init, so that's okay. And then use it like normal, and then after we've finished using it down here for the create vertex array, we will call delete on it to free that memory. Okay, good. So I think that's literally it. I just need to review the initialization because I went and renamed a few things in the shader. So the sprite components, yeah, that's fine. Entity indices is used for selectively going through entities, which we're not actually doing at the moment. Vertex array handle, yeah. And this is the representation of the vert. So we do in pos, in UV, and in text ID. That's identical to how we name things in here. The naming in here doesn't actually matter, but it does matter when we set up the format. So let's take a look at how we did that. And so we register the scene draw function and the component type. We got the initialization data for the index buffer. This is where we create the array. It looks like I didn't actually finish this. So for creating the array, max vertices is going to be 4 times max sprites. Max indices is 6 times max sprites. The stride is going to be the size of the R2D vert structure, which represents the vertex data. Oh, I didn't see it pop in. It's that time again. Did I pop in at the wrong time? There's never a wrong time to pop in. Pop in whenever you feel like. But yeah, then the vertex layout, vertex data. So the layout is incomplete. I think I'd started this and then lost track and did something else. So the vertex layout here, this is actually where I specify the layout of the data that goes in, that binds to the inputs on my shader. You said something about a dryer. Yeah, no, it's, in a few minutes I'm going to need to go and turn over my laundry, but I'm going to wrap this up real quick before I do that. And hopefully I'll get some colors on the screen in a second. So I need to actually set up the other variables now. In pos, we need in UV, which is a vec2 that there's only one of, and it's in UV. I think is, if we take a look at the structure, we're getting the offset of in UV. Yeah. And then we need in flat int in text ID. This is just a int. We're only doing one. It's not like an array. And we need to do in text ID. I think it's called a text ID inside the structure. Not you. Yeah, in text ID, good. So this gives us the relative offsets inside the structure. And actually don't have any other vertex attributes to handle here. There's just the texture slots uniform buffer, but that's handled elsewhere. And yeah, I don't have like a frame buffer API set up right now, so the outs just automatically goes to the color buffer out. Cool. And where do I do that uniform buffer now that I'm thinking about it? Did I create the uniform buffer anywhere? Well, it's not a uniform buffer actually, it's just a sampler uniform. So this automatically gets parsed out when we go to compile the shader, or introspect it out, I should say. So we already have the rest of these. When we go to use bind texture, it automatically binds using its name, so I don't actually need to do anything on that front. I think we're probably good. Why does it still say that I'm using too much stack? Maybe it's just a leftover warning from the last time I tried to compile. I think that must be, because now I've moved it to the heap. And that's the only sizable thing that I allocate here. Okay, so I think that's looking good. Yeah, so let's press F5 and see what I broke. See what I broke this time. Oh, I didn't bind the shader. I'm realizing right now that I have a problem. Or no, I do bind the shader here. Yeah. So in this context, I would probably want to do the shader binding within the renderer. But in the future, this will use a material system that will allow me to use whatever shader I want with whatever parameters I want, and it'll just smartly handle it inside the renderer 2D. So test renderer 2D. Yeah, and are we loading the right file name? I might have renamed it. Load shader file, test renderer 2d.glsl. Yeah. And we're loading from test2dscene.yaml. So, okay, seems to be possibly in order. Okay, it said done building, so at least it compiled. We'll see what doesn't work in a minute. Okay, so we compiled, but we got some warnings. What do they say? Unable to bind shader program and no fallback program has been set. And because the shader program didn't bind, we're also having consecutive errors for trying to bind the texture. So we go to compile shader source. I'm going to set a breakpoint and identify where things go wrong. So this is EP null shader is the first shader that compiles, so we'll continue. And now we've got the source code for the shader program that we're using now. Looks like it's got everything in it. So I'm going to first, and I'm not going to step through all of this right now. I'm going to go to the very end and see what happens. So I tried to go to the very end, and I see that it actually just goes straight past this point. So it never actually executes return true. So it does break somewhere in the compilation process. Let's do that again. Continue. Now we're looking at the right shader file. And I guess we'll step through until we find a problem. Okay, let's go to the for loop. Okay. Cars to line start. Oh yeah, it's not initialized yet. Cool. So now we're parsing through the file. Maybe the issue comes later. I'm going to skip the parsing section. EP assert current shader source strings has 8 members. Yep, good. Continue. So now we've got every buffer filled up for compilation. No warning so far. So I'm willing to bet the issue comes in here somewhere. we're only expecting to compile a single variant. That's correct. Because in this example shader, I'm not using the pragma option statement for doing multiple versions of the shader. Okay, and then this is down where we actually do the compilation. So at this point we are on OpenGL, we're calling GL create shader, and we're going to be uploading the shader source to those shaders, and then attempting compilation and linking. No OpenGL warnings yet. We just called compile shader on the vertex shader. No warnings. The compilation result was false though. So there was a failure to compile. If we proceed, I will be printing out a copy of the source and then deleting it. So let's take a look at the pre-processed source. So this is a copy of the source that was assembled from the include statements and so on and so forth. This is supposed to represent the vertex. Version 110, define EP vertex. Yeah, we got the standard uniform buffers. Uniform sampler 2D, texture slot 16. In vec3 in position, in vec2 in UV, in flatten. Oh, I think that's the problem. OpenGL does not allow flat after in out. Got it. Okay, so I this is just my ignorance in GLSL. In GLSL, you have to specify flat on the out of the vertex shader. Flat just indicates that you're telling the shader that it doesn't have to interpolate between the values. It doesn't have to vary. It used to be called varying, I think, where you take whatever values you set in the vertex shader. Those are like linearly interpolated between points, so that way when you're looking at the fragment, it's got the in between value between the values you set on your vertex. So I just put flat in the wrong place. That's simple enough. I'm going to be eventually doing a more robust warning system where when I have issues that like result in logging an error every frame, that it doesn't just like flood my console and prevent me from seeing the stuff up on the top. But that's a little ways off. I got to get text rendering working first before I start doing a new console. Yeah, so coming back to VS Code, oops, I didn't mean to open Discord. It sounds like the problem is just this. Though it did say in out. Let me just look this up on Google. Because I know that I need to provide flat when I'm doing an integer instead of a float. I just don't remember the exact. So you do flat before in out. So flat goes before. So it must be not so much that I did it on the in, but that I did in and out afterwards. Okay. Hopefully that's all there is to it. Let's see what happens. Okay, we got something. Okay, so we still have a problem, obviously. But now it's using at least using my fallback shader. So I have a hard coded magenta shader that's supposed to tell us when there's an object in the scene that's not got a valid shader loaded. So there's still a problem with the shader, but um, at least this time it's rendering some geometry, which is new. So let's see what that looks like. Enable the bind shader program and no fallback shader has been set. We try to set the texture slots on the EP null shader, and of course the sampler doesn't exist in the null shader, so that's fine. It just ignores it. Yeah, and the geometry is also wrong. So I'm gonna go ahead and grab my laundry, get it out of the dryer, and then when I come back, I'll be looking at what is wrong with the geometry and what is wrong with the shader. Probably be 10 minutes. Alrighty, I'm back. Just had to take my laundry out of the dryer. Anyway, where I left off, I got this weird situation with this shape that's decidedly not a square. So the way that I had the scene set up, let's open up the scene file we're loading. There were three entities, sprite 1, sprite 2, sprite 3. One should be located at x5, one should be located at the origin, one should be located at x negative 5. So there should be 3 quads in a row with 3 different sprites being loaded. They should all have, all their UVs look correct, going clockwise around. But what we're seeing is apparently the right quad only, and it is got one of its points pointing back towards the origin, so there must be something wrong with how I'm constructing the vertices. And in addition, it is magenta because my shader isn't loading correctly and it's using the fallback shader. So let's head back to the shader, compile shader source. I'll throw a breakpoint again at the compilation stage. So compilation and linking, compile vertex, compile fragment. So I got to put one here. I'll put one here. So immediately before the return false calls. You know what would probably be a smart idea would be to actually just do a debug break from code, and then just leave it in there in the source code, so that if I encounter the situation, I'll just have the option to inspect it right then and there. Let me do that for the compilation and linking stages. Press F5. Okay, let's take a look-see. Qualifier, flat smooth perspective cannot apply to this type. That's happening on line 32. Line 32? 032. I'm not sure what that means, but it's an OpenGL error. So I guess that's probably the input. So down here we got in vec3 and vec2. I got flat in int and flat out int. So I think this should just say in int. But I'm not 100% sure on that. Let's go back to the shader, test render 2D, and I'll get rid of the flat on that guy. Okay, we still got a break. OpenGL does not allow flat after in out. Am I using that somewhere? Oh, I forgot to change it in the vertex shader. I changed it, or the fragment shader. I changed it in the vertex shader, but now it's the fragment shader that's failing to compile. So let's fix that. I'm just not very experienced with shader writing yet. I'll get there, but right now it's a little dodgy. So it's got to be flat in instead of in flat. Let's give this a shot. Okay, well, it's at least compiling, but hang on one second. Sorry, somebody needed my attention. I'm back. So now the shader is compiling, but I don't see any of the characters that I thought were going to be on it. And we still have the geometry problem. Taking a look at the notes, it says sampler uniform does not exist when I try to bind to texture slots 0, which is interesting. Because I'm pretty sure that these come in when you do introspection. They come in as texture slots. Oh, I'm missing the T. Oh my gosh, it's always a spelling error with me. Oh my god. Oh my god. It's always a spelling thing. I don't know why I'm always doing that. So if I go back to make sure I got the spelling correct in the renderer 2. Yes, I have it correct there. All right. All right. Still a problem though. Sampler uniform does not exist. Program test renderer 2D sampler texture slots 0. So it's not just that it's misspelled. There's also a problem with the introspection maybe. Let me go to the renderer or the compiler. Compile shader source. And let me go to the introspection phase and see what kinds of sampler uniform names I get. So they'll be down here. Okay, so get active uniform name, name length, types, program, address name, OGL. Okay, here we go. So I'm looking at OGL string out buffer. So it's coming in without the T again. Oh my god. I feel like such a fool. What I did is I made the correction and then I didn't hit Control S and I just assumed that it would save because it's, yeah. You ever have just one of those moments when you don't understand basic suvat? I don't actually know what suvat is, so I'm not sure. And so probably I feel that way all the time because I don't know what suvat stands for. Equations of motion. I'm gonna go ahead and pull up the link you just linked in. Yeah, no, I get you. In fact, I probably don't have. I probably am farther behind it than you are. I've never had to use these equations for anything. Are you doing something with physics? Doing a simulation of some kind? An n-body sim, yeah, that sounds like fun. Simulations are like complicated for me to understand. I like playing with them. I just don't think I would do a very good job programming one. On my side though, I no longer have compilation errors. It seems to be binding correctly to the textures and all that stuff. And we're no longer seeing magenta, meaning that it's actually using the shader. But I should be seeing a texture here, and I'm only seeing black. Like, even if it was distorted, I should be seeing a distorted Hollow Knight or a distorted Link or Celeste here, or Madeline from Celeste, because those are the 3 textures I'm using. So what am I forgetting? InPos and UV. I suppose what I could be getting wrong is the UVs. It might be that it's, for example, what if all of the UVs were set to 0, then it would just be black on all of them because they're all black on the corner. So let's take another look at the renderer code. And let's just set up a breakpoint and step through it. Okay, so we've got num of components 3, good. So it's apparently serialized or deserialized the components, or all of the components, not necessarily correctly, so I need to inspect that now. Alright, so let's start with the first one. So entity ID 123456, which was the first one, sprite 1. It's got a texture handle of 1. And it's got UVs of 0, 0. Except for it says XRS for the type. Am I... Oh, that's because of the way that vec2s store. I forgot about that. So vec2s are actually, they have, you can either use X, Y, Z, or RGB or whatever. So X, Y is 0. X is 1. Y is 0. X is 1, Y is 1. X is 0, Y is 1. So it looks like the UVs are coming in correctly. And they are identical for all of them. So at least the UVs as they are deserialized appear to be correct. So that's good. They also have all unique texture handles, which I would expect because they are 3 different texture file names. When I go to load the textures, it should identify those as separate and give them all separate handles. So let's step over these and see what we get in the verts. Okay, so inspecting the verts at 0, we've got in position 5.5, 5.5, 5.5, 0.5. Yeah, that's very wrong. How about the in UV? 0, 0, it should be 0, 0. Yeah, so I think there must be a misunderstanding about how GLM is doing the order of operations here. So what I'm going to do is, instead of doing the wrapping of the GLM scale with the cast of the rotation, I'm going to do it a little bit simpler. I am going to do GLM model mat equals GLM translate GLM mat for 1 to get the unity matrix or the identity matrix, and then do the position. And then do times, and I'll just do these separately. So we'll do times GLM scale needs to be, actually I need to do the rotation first, so that would be scene manager get entity rotation cast to mat4, and then do the scale, GLM scale. Do the unity or the identity matrix again. And then get the scale vector. Oop, boom. So if I was misunderstanding how this worked, the left to right versus right to left when you're doing the nested GLM calls, then it should correct it, because now it's all right to left multiplication order. Let's give it a shot. See if that at least gets the vertices in the right places. It does not. It does literally the same thing. Okay. Don't you get a GLM rotation matrix from a quaternion just by doing math forecast? In this case, they did GLM2 mat4, which I happen to recall is just a wrapper for math forecast. So that must be correct. Maybe it's the data. Maybe if I review the rotation w, x, y, and z. I thought that this was a 0 rotation. So like if you're not wanting to do any rotation at all, then the quaternion is, oh my gosh, it's wrong. It's this lists the quaternion as XYZW. Yeah, I should be doing WXYZ. So actually that's probably the issue, I think. I don't understand quaternions enough to know this one off the top of my head. Okay, so hopefully that's the problem. Well, it did certainly change something. All right. Cannot deserialize entity invalid transform values. Sprite component data found for entity ID that isn't present in the entity section. So what did I change? What did I mess up? Oh, I didn't put a Z0. Okay, so that's certainly better. We've got 3 of the 4 points where they should be for this one for this one sprite, but I still am missing 2 others. Something that might tell me a little bit more about where the others are located would be if the 3 sprites were different colors. So I'm going to go into the shader, this guy, and instead of doing final color, the texture of the whatever, I'm just going to do final color being red, blue, or green depending on the text ID. So I'll do final color equals, I guess I'll do switch text ID. I'm pretty sure switch works the same way in GLSL as in C, but I guess we'll find out. K0, final color equals let's do a red. And then we'll do blue and green for the others. Oops. Visual Studio and Visual Studio Code have very slightly different quick keys for text editing, and it always trips me up. I'm always juggling between those two and Xcode's keys. Yeah, and that should be enough. So, unless I am misunderstanding switch cases in OpenGL, it appears that I am. Give me a second. Sampler uniform does not exist. Sampler texture slots. Oh, because I'm trying to bind to the texture that I've now optimized away. I'm not utilizing texture slots anymore, so it's, yeah. But it's not giving me the output that I expected either. Okay, so it does do switches. But if the color is always red, blue, or green, so that would imply there's something wrong with text ID, because it should either be red, blue, or green, the color I'm looking at, depending on what's on top. So let me check that out. Default, and set final color to just be all white. Okay, that tells me something. So the text IDs that are coming in are not in the range 0, 1, 2, 3, which is totally not what I expected. So let's figure out why that's happening. So presently there's no used text slots. Oh, I'm an idiot. Okay, so I did something wrong here. Stop. So what I was doing is I was first checking to see whether we have already bound a texture, the texture that we're looking for, into one of the text slots. And if we did, then what I do is put it in the vertex array. If I don't, I bind the texture, but then I forget to follow that up with putting the texture in the vertex array. So I need to actually do that still. So what's probably happening is that it's receiving an uninitialized value. Because if it was 0, then it would show up as black still, or show up as red with the new shader. So I need to do ID assignment. Cool. Yeah, and I could probably put this outside of this whole thing because it's literally the same. But for now, I'll just leave it and figure the rest out later. Okay, now we see red. And we got a bunch of warnings for the sample uniform, but that's okay. We actually were expecting that. Because we see red, that tells me that this is that all of the fragments that we're looking at here are for texture slot 1. So case 0 does the color red. Which is kind of surprising, isn't it? Because I thought that we would be doing the first one would be assigned to 0, would be drawn last. So let's step through this loop again, and we'll check the data for each. Actually, what I'll do is I'll go past this loop, and I will inspect the constructed data at the end of it. Yeah. Okay, so verts. Because verts is a pointer that's allocated with alloc A, I think I'm going to need to do a watch 1 window and manually type in these addresses. So what we'll need to do is verts 0, verts 1, and verts 2. And this will let us inspect the data for each one. I actually need verts 3 as well. So this is for the data for the very first quad. So for the first quad, we've got an X position of 4.5 and a Y position of -0.5. So this one is the one located on the right, which explains why we're seeing the color red for the one on the right. Second quad is 5.5, so 1 unit over on the x-axis, still the same value on the y-axis. Now we've got 5.5 on the x, so it's still 1 unit over, and 0.5 on the y, so it's gone up 1. And we got 4.5. These position coordinates look correct. It is going 4.5, -0.5, 5.5, -0.5, 5.5, 0.5, and then 4.5, 0.5. That's the position of all the vertices. That's where they should be. So if that's correct, then the issue must be on the index buffer. That's interesting. I thought that was the most run-of-the-mill part of this. Let me stop for a moment, and I'll head back to the init function where we set the index buffer, and I want to actually inspect it. Here we go, index init buffer. It's also a pointer, so I need to do index init buffer. Do I really need to do a call for each one of these? I guess I do. Index init buffer is actually just a pointer. And when I go to inspect it, it's treating it just like a pointer instead of a array. So I'll have to manually access the elements for a minute. My typing is atrocious. Alright, so here's the first 6 indices. So we got 0, 1, 2, 2, 3, 0. That's what I expected. And we should have 4, 5, 6, 6, 7, 0, 6, 7, 4. Yeah, and that's exactly what we see. And then it goes right up to 8. Yeah, so if the index buffer is correct and the vertex buffer is correct, then what in the Sam hell could be left? Maybe there's something up with the model view projection matrix. But there really shouldn't be, because that's tried and true code at this point. And the fact that... Come on. Oh, is it going to keep hitting me every loop? The fact that the camera kind of still operates correctly, like I'm still able to like rotate and move around in space without the directions being weird, suggests that the MVP matrix is correct. It's just the vertices that are wrong. They're just not putting together why they're showing up differently in my inspector. It is curious, though, that it's only happening on the first 3 points. So we've got a valid index buffer, we just inspected it. So for max vertices, we are passing 4 times max sprites, and then 6 times max sprites for the max indices. Maybe there's something up with my draw triangles call. Maybe it's not correctly doing all of the elements. Because in my previous testing code, looking at the stuff I commented out, I would use the default values. So I would just pass it the handle of the vertex array I wanted to draw. Okay, that's enough in body. It's more difficult than I thought, but I think I have to manage. Yeah, dude. Nice. Yeah, it feels good to have something complicated like that working. So let me go back to the renderer code, take a look at the draw set vertex data and the draw triangles call. As an experiment, I'm going to take out these extra parameters, get rid of the optional ones. What this will do is it should draw every single element in the handle instead of just the 3 quads I need. Same difference. Okay. Speaking of complicated, I'm about to inflate your ego 1,000-fold. Earlier I was streaming working on my static site generator, and I ended up debugging a weird bug for 1.5 hours, and the bug turned out to be moving one line above another line accidentally. I was freeing data that was still, yeah, oh boy. that must have been such a relief slash infuriating moment when you found that. I've totally done the same thing. An hour and a half, yeah, that's life as a coder, man. I don't know if that inflates my ego. that's just how it is. I've been there. I'm probably there right now. Whenever I find out what's going wrong with this, but on the plus side, I've learned GDB. It didn't help me debug it, but it's nice. Yeah. And now you can put that on your resume. Yeah, I'm not figuring out what's wrong with the transform. I'm going to go back to showing black in the shader, or showing the texture technically, just to silence those warnings with the buffer not being available. Oh, we got something. We've got the texture loading now. Good. Okay. So the index buffer is bugged. Yeah, I inspected the index buffer, and it seemed to be constructing correctly. Yeah. So yeah, it sounds like you've got, the fact that you know what an index buffer is means that you probably have enough to understand what's going on. On this one, I am constructing the when I make the vertex array handle, I am telling my graphics engine to do a vertex array and a vertex array buffer. Sorry, vertex buffer and an index buffer at the same time, and I'm telling it to make a vertex buffer that's dynamic so that I can stream in new vertices. But then I'm setting up the index buffer ahead of time for the quads, because it's always going to be in the pattern 0, 1, 2, 3, 0, 1, 2, 2, 3, 0, and then do that again from 4, 5, 6, 6, 7, 4, and going up. That appears to be correct, because I was inspecting that array, and as far as I could count, it was always showing the correct indices. But for one weird reason or other, we still got only the one quad showing up, only the first one. And its fourth or fifth point, I should say, is going back to the origin. 0, 1, 2, 2, 3. So it's when it gets to the vertex 3. Previous to like this system, like prior to doing all this, when I was learning OpenGL, I did do a batch renderer, and I got it working successfully using the scheme I'm using now. But it's probably going to be a typo somewhere. I guess let's review the text from the beginning. And what's this warning about? Buffer overrun while writing to verts. The writable size is number of components times 4 bytes, but 48 bytes might be written. This actually might be pretty important, huh? So this is a field of vec3. Oh, I was wondering about this. I actually wondered out loud about this earlier in the stream, that I wasn't getting a warning like I got in the previous stream, that I needed to explicitly cast it to a vec3. In my original API with my own math library, I realized that I'd be converting from vec4 to vec3 so constantly that I just made it a built-in thing, and it might not be in GLM. Okay, nothing different, so apparently that's not the problem. We still have a buffer overrun. The writable size of R2D vert. I guess I'm not following. The position that we're writing to is vec3. Is there something that I'm missing here? Maybe this is the root of the problem. This is just a warning saying that I should be using the more secure version of allig-a. There's a underscore mallig-a, which still does on the stack, but it's a little bit safer because it has a fallback of allocating on the heap if it can't allocate that on the stack, which, you know, sure. But at this scale, it can't be the problem because I've only got 3 quads going. Oh, this is what it's talking about, though. So verts is got the space of oh, okay. So actually, this warning should be wrong. What it's saying is that if I for example, exceeded the number of components, then this might be writing into memory that's beyond. But by definition, it can't be because it's in the for loop. So it should be, in this case, I've got 3 components, so 3 quads. It should be 0, so 1, 2, 3. So the max it should be is 3 times 4 is 12 plus 1 is 13 for the addresses. And we should be dealing with can I just do this? No. I'm going to do the C++ way and see if that makes any difference. I don't see why it would, but maybe I'm missing something here. But I'm going to try using the new keyword instead. and then we'll do number of components times 4, and then call delete verts when we're done. Yeah, I'm not a huge fan of heap allocation, but yeah, so it's not the allocation. I try to do stack allocation when I can, but I mean, when we're talking about allocating large amounts of data, technically there's a risk of buffer overrun, and so your compiler is just going to freak out and give you warnings. So you see that apparently by switching it to the to this format, so using the new keyword, that resolved the warning from down here, but it didn't actually have an effect on the program because that wasn't the issue. So I'm going to leave that there for the moment. In theory, this could get quite large now that I'm thinking about it, because we're talking about allocating for a vertex for every quad on the screen, and for a big game that could be thousands and thousands, even with culling. But yeah, I'm just going to leave that the way it is right now, and then come back to it later and decide what I want to do. But yeah, what the fuck? I should be looking at 3 sprites right now, but I've only got half of one. I wonder if I can infer anything from the way that the stretching is occurring. Because it's just occurred to me that this is stretching off to the upper left, not to the bottom corner. You would think that if the points were all consolidated at the origin, then all of the texture would be going that way too. But it seems to be going up to the left, like forming a parallel line with the bottom edge here. Does that tell me anything? Why would it do that? If this is parallel, and admittedly it's a little bit hard to tell with the perspective projection that I'm using, but going square on, it kind of looks like it's parallel. And I can assume that its UV coordinate is going up to some invisible point up here. That is 1 unit up from the origin. But if there's a vertex up there, then I should be seeing it. Like, it's not going to interpolate to a vertex that doesn't run through the vertex shader. I'm not using transparency, so it should be black. I think one of your verts is just misplaced. Yeah, but like, in addition to that, there's also supposed to be a quad here and a quad over here. I had loaded up 3 quads into memory. And when I go to inspect the memory, it's there. So when I go to load up using the deserialize function, at the end of it, we have all the data correct inside of the components list. So let me go ahead and inspect here and go to the components list. Components. So this is an array containing all of the potential components we might have, we see that there are 3 loaded. 1, 2, 3, 4, 5, 6 is the ID of the first one, which is here. It's supposed to be at position 500. It's the Hollow Knight one. And if we go back to, let me go to the inspector here. Locals. Oh, it's going to make me use the watch one window. If I do components at 0 and inspect it, got its ID 1, 2, 3, 4, 5, 6. The texture handle is 1, meaning it's the first texture handle that was bound successfully. So we successfully loaded the texture, and we got the handle 1 back from OpenGL. Its UV is 0, 0, 0. Or sorry, I have to open these up because of the way that GLM does RGB and so on and so forth as well. So yeah, it's 0, 0, 1, 0, 1, 1, and then 0, 1, which is what you'd expect going sampling around the UVs around the perimeter of the texture. So the UVs are correct. I suppose it's possible that the positions are not correct, because that's not handled here. That's handled in the scene system. Wait, what am I saying? We know that the positions are correct because they're being stored in the component data, and we just inspected that. Oh, wait a minute. Wait a minute. I think I might have... No, never mind. I thought I had a thought, but it turned out to be not a thought. It turned out instead to be bullshit. So translating to the entity position, casting the rotation from quaternion to a mat4, and we're getting a scale using the 3-dimensional scaling found here. Did I screw up? Oh, did I screw up scaling? If I go to scale 111 111 111, it seems to be correct. I'm going to do a quick little experiment though. I'm going to give each of these different scales. I kind of expect that this will behave exactly the same because I'm leaving the scale of sprite 1 to 1, but you never know. Maybe this will break in a weird way that will tell me more about what's happening. Yeah, it's literally the same. And if I was to do a slightly different scale for the Hollow Knight, do 0.5 on the X to make it narrower width-wise. Yeah, literally the same behavior, except for now the sprite is half as wide. Let me inspect the calls to translate, and oh, did it just skip over? Oh, I just put the breakpoint on the wrong line. Stop. No, that was the right line. But it's okay. So we'll step into get entity scale. And then when we step out, in autos, it'll tell me the return value was 1, 1, 1, which is correct. Now that I've set it back to 111, yeah. And if I step over, oh, it's breaking in the middle because it's the same line. That's why. Okay, I was getting confused for a moment. Stepping into get entity scale, out of, into, out of, into. Okay, so now we're in get entity rotation. The rotation was W0, W1, X0, X0, or X0, Y0, Z0, which is should be a null rotation, right? Does it work with one sprite? Let's see if it works with a simpler case. That's a fair point. Let's see if we have any different behavior when it's just the one. To do that, I'll go ahead and comment out these others. Cool, and then let's go back in, run it. Well, now I'm not seeing shit. That tells us something though, doesn't it? There. 0, 0, 1, 0, 1, 1, 0, 1. Okay, position rotation. That was a good suggestion. It is not rendering the simplest case of just one sprite. I'm going to put it at the origin. Same difference, it's still not visible. So what's different about these cases? I can't help but notice that 3 of the points are translating correctly and I'm rendering 3 quads. And off by 1 error, maybe. But I am expecting that there's a reason why I've got 3 points in the right place. I'm going to test that theory by adding another entity. Let's give it an entity ID of 5, and it doesn't matter what we name it, or where you put it, or whatever else. I'm just going to add another sprite. And if there's a correlation between the number of quads I'm trying to render and the number of points that go in the right place, I should be seeing Hollow Knight on the right. I am not, though. Clicking and dragging to the right. Let me put Hollow Knight in the middle, just to be sure. I keep calling him Hollow Knight, but I know that that's not correct. I've played the game. Yeah, so I should be, yeah, so that's not it. But if I go back to commenting out the sprite I just threw in, will I go back to seeing 3 correct points? No, I don't. I'm not seeing anything now. Why not? Did I change something? I doubt I changed something. Let me Control Z through what I just ran through. So this is what it looked like before. Okay, I must have changed something in the code that I forgot about. And that's giving me no drawing at all now. Okay, so this was the last time I know that it was working in the shader. When you say an off by 1 error, I want to clarify, you're talking about if I am trying to like index into the wrong place and it's like every quad I try to draw, it's off by 1 more. I'm not really familiar with that term, off by 1 error. because you said the last vertex was going to a correct position on the next quad. That's not quite what I said. So there were supposed to be 3 quads. None of them were supposed to have points at the origin. So the middlemost quad would still be like its points would be located at -5, -0.5, -0.5, 0.5, -0.5, 0.5, 0.5, -0.5, 0.5. But the point that went off to the middle was actually going to the origin. It was going to the points between the topmost and bottommost points of the spray that we were seeing. So I know that they're consolidating at the origin, or at least one of them was. Though the weird way that the texture sampler was going off and up instead of towards the origin makes me question that. Let me go back to what I was doing. Taking a look at the model matrix, making sure that it's being constructed correctly. So, well, actually, let me Control Z some changes that I made here. Trying to identify what change I might have made that would have affected the drawing. The only change I can see that I've made was this, because I know that when I had switched to doing the delete, doing the C++ heap allocation for verts, I know that that worked because I tested it immediately after. And the only thing left in my redo history is this, moving GL and translate to the next line. That should not have affected anything. Let me move it back up though and test again. Oh, now it's back. Oh, what? Oh, I'm a fucking idiot. It was there the whole time. I just forgot that. I actually have to move back to see it because I'm starting at the origin. Oh my god. Okay. All right. Let's go. Now that that's figured out, let's go back and redo the test that we just ran on this. You had suggested rather smartly to go and try the simplest case. I'm going to do that again. Now that I'm realizing that I just screwed up the way that I was navigating the world, and I just didn't realize that it was going to be invisible until I pressed the S key and moved back the camera back. Let's see what happens this time. Okay, it is actually invisible. The first thing I did is press the S key to move back, and I'm getting nothing. And if I try and pan to the right with the mouse, it's not. And just to make sure that that's the difference, I'm going to change the file again, and yeah, so it doesn't render if I just do the 1. Now the second test I was going to do was this. I wanted to test whether having a 4th quad loaded made a difference, because I thought it was a curious coincidence that the number of vertices that render... Yeah, look at that! I thought it was a curious coincidence that the number of vertices that were successfully rendering equaled the number of quads. So somewhere in my code, I am using the number of quads incorrectly when dealing with the indices. Because now that I've got supposedly 4 quads in the scene, it is correctly translating these 4 points. That tells me something. So going back to when we load everything up, we just load up the UVs as is directly into the UV values in the number of components. So it must be when we go to do scene draw with the transform. Presumably the model matrix is correct. because it's correctly translating at least those 4 points, but I must be putting them in correctly, or in incorrectly. So here we're starting off with GLM vec4 representing the 4 points of a quad in model space. So negative 0.5, negative 0.5, 0.5, negative 0.5, 0.5, 0.5, negative 0.5, 0.5. And I have the 1 on the end there because I'm going to be multiplying it against the mat4. And then I cast it back to a mat3 and I get those points. That should be at I times 4, I times 4 plus 1, plus 2 plus 3. So I should be getting the 4 vertices positions from each component. Yeah, number of components is 4, so I should be doing this code 4 times. So I'm doing the model matrix 4 times. Using its entity ID. So getting its entity position, rotation, and scale. So I'm inspecting the verts. I think earlier what I had done is I had inspected all the verts before it was sent off to the GPU using set vertex data. Let me skip to that point now. And let me inspect the verts, which is a little harder to inspect verts than you would think, because I have to actually manually type in 0 and 1 and all of the indices because it's actually technically a heap allocated array. There must be a better way to inspect that kind of data, though. Oops. Come on. Can I just, yeah, whatever. Let's inspect what we've got. So position of vertice 1 is 4.5, negative 0.5, and the last is 4.5, 0.5. So that's looking correct. I'm going to stop and remove those, comment out those other components again, just so that we're down to the 1. And I want to see where that puts the vertices. That actually puts the vertices at the right position again. The first 4. Yeah, it goes 4.5 to 5.5 on the x-axis, and it goes negative 0.5 to 0.5 on the y-axis. So that actually looks correct. But we already know from before that if we turn off that breakpoint and continue, that the sprite doesn't actually render, but its position is correct. So that leads us back to thinking maybe there's a problem with the index buffer, but we inspected it when we created it here. And like, I know this works because every test renderer that I've written before trying to integrate it with the ECS system, every test renderer I've done has worked correctly when I do this, when I do 4 times the number of sprites and 6 times the number of sprites for the vertices and indices. But in the spirit of gut checking, there's got to be a better way to inspect heap allocated arrays. Zero, 1, 2, 2, 3, 0, and then 4, 5, 6, 6, 7, 4 should be next. So this means that at least the first two quads should be fine. Pause UV and text ID. Yeah, that's correct. I'm realizing that right now that in my implementation I didn't wind up using a default quad because I was always setting the position and the text ID directly anyway. Yeah, thanks for stopping by. Have a good night, and thank you. Hopefully I'll have all this done in short order. I don't want to be doing this forever. But, you know, it's... yeah. That's how it is. Have a good night. I'm going to go ahead and take a break. I might actually just end the stream for a little bit and then come back later. So I've got a couple things I needed to do. But yeah, I'm kind of stumped on this one. The thought might occur to me what the problem is doing something else. So I'll be back in a little bit. Alrighty. Took a minute to get a drink and catch my thoughts. I'll probably be wrapping this up soon, whether or not I have the thing working. But right now I'm trying to figure out how come all the vertices are not going to the right spot, except for when I have four times as many entities as points, or if I stated that correctly. Basically, I noticed the correlation that if I have 4 entities in the scene, and I go to render, then all 4 of the first sprite's points render. And then if I comment out one, then only the first 3 render. And so I've noticed that there's a direct correlation there between whether the points get to the right spot in the vertex buffer overall and how many entities are in the scene, which tells me that I am screwing up somewhere using the number of components. So let me do a Control F search on number of components to see if I'm misusing it anywhere. Number of components. So when I go to load up a component from the scene file, I'm using it as the index into the component buffer. And then I increment the number of components as soon as I have confirmed that the that every value is visible in the YAML file, and that the texture loads correctly if it needs to load. So that seems to be correct. Going back into the scene draw function, I am so in verts I am allocating a little buffer that is the number of components times 4. So there's 4 vertices for every quad, which, you know, adds up. I then do a for loop for every quad. And for every quad, I do a model matrix, multiply the points of a quad in model space. That's 1 unit by 1 unit around the origin. And this actually handles scale as well. So if I was to scale up to make a sprite, the entity containing a sprite 2 by 1, then it would do that in this transformation. I am assigning it to the first 4 vertices. Following the index number of the component, which is correct. Doing the same thing for UVs, except for I don't have to do any transforms, I just look it up. Then I handle loading textures. So if the texture has not been assigned to a slot yet, I bind the texture to a slot and then store it and pass the ID to the other. And then I go to draw. And that all looks fine. So when I go to draw, I pass the vertex array handle, the pointer to the vertex data buffer, so the buffer containing all the vertices. I'd say that I'm starting with the first one and going through number of components. If I was to just oh, this is it. This is the problem. Okay. I need to send 4 times the number of components to the GPU, because I'm sending four verts for every. Oh my gosh, that's it. I think it just solved it. Let's try it out. It was just a stupid oversight on my part. Yes. Okay. Cool. So we've got sprites showing up now with 3 different scalings, and the scalings are because in the scene file I set the scale to be 333, 22, and 222 in this one. But that's interesting. I actually duplicated the sprite value there, or the scale value there, so just use the first one. But yeah, that should be it. Now the next question is, why are they all the knight from Hollow Knight instead of being all different sprites? Okay, well at least we got problem 1 figured out. I was sending just the first X number of vertices out of all the vertices, and so the remaining vertices were probably consolidated about the origin. So yeah, now that we've got the sprites rendering, what I should be seeing is the knight on the right, and either Link or Madeline from Celeste, and these other 2 sprites. So why am I not seeing that? Heading back to the shader. This is the shader we're using right now. We are rendering texture from texture slots, text ID. So this would suggest that the texture slots at 1 and 2 are not correct. I'm going to use this little tester I ran earlier to have the color just be red, blue, or green, depending on whether it's 0, 1, or 2 on the text ID. So let me confirm that at least the texture IDs are being handed out correctly. They are not. They are all red. And if I take a look at the error that I've got going on here, sampler uniform does not exist. Yeah, that's actually expected. But that's expected because I'm no longer using the texture slots, and the GLSL compiler's optimizing that uniform buffer away. But yeah, this should be red, blue, and green. So I know that the text IDs are wrong when we get to them. So let's go over this logic. Go into the debugger. So number of used text slots. So right now we don't have any used text slots because we're assigning the first texture. So the first thing we do is we assign text slot at J to be the texture index loaded in the component at I, and I is the index into the component buffer that we're rendering. Okay, so the first thing that happened is I called bind texture to bind to texture slot 0, and I should get a warning when I do that because right now I'm not using that, so it's been optimized away. And then the next thing I do is I set the verts for I times 4, I times 4 plus 1, plus 2, plus 3. All of those I need to set the ID to the ID that we just used. So the first one is correct. All of these should be 0 because this is the first. I'm not incrementing number of used text slots. That's the problem. It's always something simple, and I always feel like an idiot and a genius when I fix it. But okay, cool. Now we got the correct colors indicating that these are being rendered with different texture IDs. So now the remaining thing is to just get them rendering their appropriate textures. So going back into the shader, I'll change that over to sample the textures. And we were so close, weren't we? Okay. And I've got errors for texture, the sampler uniform for 1 and 2 not existing now, which is interesting because they totally should exist. Texture slots 0 through 15 should exist. But I know why they don't. Okay, so this problem now arises from an issue with how I am introspecting into the GLSL program. I am not considering the case where there's an array and I need to get the remaining elements of the array. I kind of knew that to an extent because that's how I was binding the textures. I was using graphics bind texture and binding it to the texture name, texture slots in slot 0 and slot 1 and slot 2 and so forth. But I'm realizing now that that's not how GLSL works. When you go to introspect the uniforms, it will give you the first one to indicate it's an array. It'll give you brackets 0 bracket, but it won't give you the rest. It'll just tell you how many elements are follow this one. So I'm going to need to do some graphics API work now. But yeah, we're on the right track at least. Now I've got the 3 sprites loading just as I thought they should, using the scene system. And if I go into the scene file and manipulate the locations of things, it'll automatically update, it'll automatically handle that stuff in the game. So if I go to make non-uniform scaling on the 3rd sprite and go to run it again, see uniform, not uniform. So this is 2 units wide and 1 unit tall. Cool. Yeah, even just seeing this much is really nice because I've done a couple of toy renderers in the past, getting ready to do a renderer in my game engine, but I wasn't able to at any point before get it to run off of a data file. So this is looking great. So let's get this figured out. So to do this, we're gonna have to go back into the GLSL parser, or compiler, I should say. The compile shader source, this method, does an awful lot. For starters, it does parsing or pre-parsing through, so it'll take and find when you're working in the vertex shader or the fragment shader. It also does include files. It also does variants, which I haven't really gotten into yet, but if I do pragma option and specify, a basic option off with the underscore, and I can say like skeletal to indicate that this works with the skeletal system. I can do stuff like that. So it does that, and it compiles multiple versions of the shader through the parsing. And then after we do the compilation and the linking, we do introspection and get the names of the stuff we care about. So that way I can just address them by name using the graphics API. So if we go to sampler uniforms, we don't actually support uniforms that are for not samplers. I'm making it a requirement in Enterprise that if you want to send uniform data, that you do it in the form of a uniform buffer. So that looks like, like one of these. And then that data will persist between shaders, and it's more efficient because you can actually just, instead of having to send multiple versions of the data for each material that uses a particular shader, you just bind the appropriate uniform buffer prior to your draw call, and it just swaps out the data without doing a whole bunch of memory stuff. Um, but yeah, in the introspection, I need to actually have special handling for the case that we have the bracket 0 and whatever at the end. So reviewing this, sampler uniforms, so get program IV, program uniform max length, uniform length. So get GL active uniform max length gives me the length of the longest name in the list of uniforms, which I use to make sure that I've got an output buffer that's large enough. And I literally just allocate these on the stack. And in order to prevent there from being like continuous reallocations, I will only reallocate if the previous buffer wasn't long enough. I might, considering how many variants I'm doing, I might actually, for safety, just go in and do an on the stack like 1024 bytes, something that's just like absolutely will take care of it, and then I don't have to do this logic. But for now, I'll leave it because I know that it works. We go through the number of active uniforms, so we're iterating through the uniforms now. List indices. So we're getting the index of each for use down here. GL get active uniforms, IV, program count, OGL, uniform list indices, block index, and type. So now we've got the type of each uniform and the block index, which I don't quite exactly remember. But yeah, so the block index is just to confirm that it's a uniform and not a uniform buffer. If you put braces around it, it becomes a block. So if it's not a uniform buffer, if it's actually just a uniform, then we confirm that it's one of the types that we care about. Sampler 1D, 1D array, int sampler 1D. So these are just literally all the sampler types that I know I'll eventually need in a game engine. And then at this point, we get the name. And that goes into OGL string out buffer here. So let me confirm my hunch first by going through and parsing this. So for starters, yeah, this is test renderer 2D. I'm checking the shader name from the program. We've already compiled it at this point. We are introspecting. So we've got the OGL string buffer. So the first one that came out is texture slots 0. And if I continue, it literally doesn't get invoked again. So we're only getting the one buffer when we inspect this. So I now also need to get the number of these. And decide how I want to handle this in the uniform. Let me step over this for a second. I'm going to, at this point, pull up Khronos has a page about program introspection on their site that kind of goes over this. So I am checking it. So there's interface block arrays, which is not what we're dealing with. So I guess it would just be arrays. Arrays work differently depending on whether they are arrays of basic types or aggregates. So structs or arrays are aggregates. Arrays of arrays requires OpenGL 4.3. or the ARB, arrays of arrays extension. We don't have the extension and we're using OpenGL 4.1. That doesn't apply to us. An array of basic type represents a single resource. Struct aggregate, yeah. An array 0 is a single resource of type vec3, which has an array size of 7. There is no resource named an array 3, just for index 0. Note that the array index can be removed in these cases. Thus, the query by name APIs will accept either an array or an array 0. But if you query the name, you will always get the 0 version. So I can actually keep keep the array with the array name with the brace for query by name stuff. I don't actually have to remove it. But for me to bind to a specific element in the array of samplers, I'm probably going to need to change my API for binding textures. Let me take a look at the bind API texture. So presently the way that it works is that I have a texture handle, which was returned to me by OpenGL when I go to load a texture into graphics card memory. And then I literally just pass it the hash name of the uniform. So for the simple example of just having a single sampler 2D, that works great because I can just use the same name that I have in the GLSL code, and it'll automatically bind it to the correct location. But in the case of a array, I also need to pass it the index. And that doesn't really play nice with this at all. Because if I was to, for example, make an additional parameter on here, like an optional parameter for the element, and then like have an optional 0. Optional 0 doesn't work because 0 is a valid element. So I mean, like I could do like optional -1, and then I'll put it to like npos to the very highest element, and that could be an error check or something. So like I would say, if it's equal to -1, then we just treat this as a single type, as opposed to an array type. But I do need to get the get a way to bind it to the next elements. That might tell me a little bit more about how I should structure my API. Heading back to shaders.cpp. So I'm using get attrib location to get the location used by GL vertex attrib pointer. So in the game engine internally, the API will get the location and then associate that location with the hash of its name, so that I can just call bind. It'll look up in an STD map somewhere what location is associated with that hash name, and then bind it. Or get active uniform name. So what I need is the ability to bind to the one after. So it looks like I'm going to need to do another line here to introspect. So I need to do GL uniform size. Be sure, yeah, I'm not using that anywhere so far. So let's stop the introspection and just work on the code. So I'm going to, first of all, duplicate this line and then change up what I'm getting and where I store it. And so now I'm going to store the size of the uniform in OGL uniform array sizes. So this will allow me to store every uniform array size, and if it's not 1, then I will treat it as an array. And then I need to allocate in the correct location as well. So yeah. So I was just questioning in my head whether these allocates are warranted. I think they are, because what it's going to do is it's going to only do allocate whenever the new list size is going to be bigger. So it's not like we're doing an allocate for every single variance of the shader that we rendered. So that's probably fine. Okay, so now I've got array sizes, so now I can look up into OGL uniform array sizes at the same element that I look up these others, so that would be I, and know whether it's an array and how many elements to store. Now I need to know the correct call for binding to it. So if I go to docs.jl, get uniform location. I'm trying to remember how so I literally will query the name of the query by passing the name of the uniform, which up until now I've been querying by name with the brace and the 0. And now my question is whether that has to be like whether I have to like modify that string to append all of the other elements in there between 0 and count. The array element operator and okay, a second. Uniform variables that are structures or arrays of structures may be queried by calling for each field within the structure. An array element operator and structure field operator may be used in name in order to select elements within an array or fields within a structure. The results of using these operators is not allowed to be used in another structure, an array of structures, or a subcomponent of a vector matrix, except if the last part of name indicates a uniform variable array. The location of the first element of an array can be retrieved by using the name of the array. Except if the last part name indicates a uniform variable array, the location of the last element of an array can be retrieved by using the name of the array, or by using the name appended by 0. So this tells me that I've actually got to construct the string. So in the example of texture slots 16, when I query the array name length, I'll get 16. Whereas it'll just be 1 for whichever uniform if it's just a variable by itself. I then have to construct every string in a for loop with the number followed by a brace, which is, great. The name length is only going to be as long as the longest element. So or the longest uniform name. So in this case, when I get back texture slot 16, I'll actually be getting texture slot 0 in braces, and that will be the maximum length of the string. So I'm actually going to need to potentially allocate another string to do this, which I'm loving. So in the interest of simplifying this code, I'm actually going to go ahead and get rid of all this alloc stuff. I'm just going to allocate a sizable buffer at the beginning. Presume that none of the names that are going to be written in the shaders are going to be longer than 1,024 characters or 512 characters or whatever. And then just not bother checking with the long names, because that's going to be, it's going to make things a lot simpler if I don't have to have those checks. So these I will leave the same, but the string out buffer, it looks like I was doing a initial allocation here to say that I am going to presume that most of the strings are going to be 50 characters or less, and so I'll allocate a buffer of 50, and then only if the string that I require is longer than that will I reallocate. Which, frankly, if that's my attitude, I might as well be doing this on the heap. So what I'll do for the string buffer then, I will now comment this out, do a GL car array called OGL string out buffer, make it 1024 characters long. And then every place that I'm using this should just have given me warnings, and so I see that. At this point I am using get program IV. The purpose of this entire block is to make sure that I've got enough room for the name and the string out. Which I'm not going to need to check now. But let me confirm that I can safely limit to 1024 characters. Using the count 1024. Params. So if I use it, if I used GL get active uniform block name, I do pass it a buffer size. Specifies the size of the buffer addressed by uniform block name, which is the address of an array of characters to receive the name. So I can set this to 1024. And then it'll safely contain within the 1024. And the worst case scenario is that I won't be able to load the I won't be able to use the shader because of a problem introspecting the uniform address, in which case the magenta shader will kick in and the dev will get a warning anyway, so I'm okay with that. Here this check is also just to make sure that the OGL string out buffer size is correct. Don't need it anymore. When I go to get program IV, I'm getting the values. Why do I do this? Get active uniform max length. Because the next OGL string is later. I guess I do the allocation up above because I use it in a for loop, so I don't want to be checking and reallocating throughout the for loop, but I don't need that anymore. Instead of passing string out buffer size, which shouldn't be defined anymore. Yeah, I plug in 1024 because that's the size of the OGL string buffer I've decided. All right, good. And then here's one last check that I don't need for the length. And then I'll do 1024 for that size. Okay, cool. And now I have set a limit for 1024 for whenever I need to get a string printed out from OpenGL. And that should be enough for everything I need. It would take an extremely unusual situation, like a nested, a block within a block within a block of uniform stuff to screw me over on that. But now that I've done all of that, when I go back to the introspection here, I can now safely just, without having to reallocate again, I can just directly edit the contents of the OGL string out buffer to contain the other elements. So at this point, we've got the uniform array sizes. So I can do if OGL uniform array sizes at I is greater than 1, then we need to go from element 2 through n, through this value, and introspect them. And I'm doing it this way by starting at element 2, or element 1 technically, instead of element 0, because element 0 might not, having a size of 1 might indicate that it's not an array. It might indicate that it is just a single lone sampler. So what I'll do is I'll do size t j 0. What I can do unsigned int. I'm not actually using this to directly access anything. Unsigned int j equals 0. J is less than, or it actually should be j equals 1. Then j is less than OGL uniform array sizes at I and j plus plus. And now we got to create a version of, that's a semicolon. Now I've got to get a version of the name for every other element in the array. So I already know that if I'm in this loop that this is an array type. So I already know that the second to last is the number 0, and the third to last, second to last is the number 0, first to last, or is that just last? The last is a closing bracket, and then the one after that is a null termination character. So what I can do is I guess the first thing to do is I got to get the position of the null termination character. So that's something I'm going to do here. Size t insertion pos equals OGL uniform or OGL string out buffer, except I can't do dot because this is not a C++ string. I would do std find first of. I would plug in the C string, I believe, and then the character I'm looking for. This might be horribly wrong, but I'll check for that in a minute. The character I'm looking for is the new line, or the null termination character. And I guess that's not how it works, so let me reference reference. Okay, so find first of works with iterators. So I mean, I could, what I'm just going to do is I'm just going to do my own search algorithm, but just to double check and confirm that there's not a way to say, what am I doing? There's strlen. I can just get the length of the string that way. strlen, and then we just pass it the string. That gives me the length of the string, assuming that's an all-terminated string, which I know that it is. So that gives me the length of the string, and then -2 will get me the second to last character, which is the number 0, which is where I start inserting. And that's why I have this named insertion pause. Yeah, so there we go. So now I've got the insertion pause. So I'll do OGL just the act of writing OGL, or writing the number into the OGL buffer is giving me pause. I don't do C string stuff very often. Which is odd because I do C arrays for everything else. So it's kind of looking like there's no helper function for this. So what I'll need to do is I'll need to literally convert the number into an integer. Or sorry, the integer into a string, and then do a for loop through that string. And man, this is messy, but whatever, I'm sure it'll be fast. So in order to get the type I need, I'm going to need to get some conversion code. So going back into my INI parser, INI reader.cpp, I've actually got a bunch of little helper functions that I wrote to do the conversions from string to number. And I'm realizing as soon as I say that out loud that that's precisely opposite of what I want. I can't use string, at least I don't want to in this case, because I don't want to do any more heap allocations, given the complexity of this process. We're going to be doing this once per uniform, per variant, per shader, so it's going to be executing a lot when we go to load something. So int2 c string. Okay, so there's a sprintf, sprintf. Yeah, that's I probably should have known that off the top of my head, but I just pass it the pointer plus insertion point, and then I can specify that, where the number of characters plus terminated character can be calculated using blah blah blah. And so after I've done that, I need to make sure that it's terminated with a null termination character. I use the buffer for all kinds of things in here. I just have a single spot for whatever string I happen to be working with at one time. That way I'm not reallocating, I'm not having to allocate like a place in memory for every single string if I'm only ever using one at a time. So I don't know. I don't actually know if there's garbage following the null termination character. So I have to assume that there is. So what we'll do is as printf, we'll do OGL string out buffer plus insertion pause. Insertion pause. I don't know how to spell. So that'll give us the address of the first character. And then percent I believe, right? Or percent D for, yeah, it is. Yeah, percent D for the other. Oh, and I can just do this. Or, I believe. Right? And then 42. And then what follows is the value that I'm converting, which in this case is going to be the number j. Yeah, I should be using sn printf. Because then I can specify the maximum number of bytes to be used. Which in this case, the maximum number of bytes would be 1024 minus insertion pause, because 1024 is the actual size of the buffer, but we've already moved insertion pause number of characters into it, so the end of the buffer is actually OGL string out buffer plus insertion pause plus 124 minus insertion pause, so it's this plus 124. Wait, no, it's not this plus 124. It's just 124 minus insertion pause. Yeah, that's correct. Okay, got checked. Complete. Pointer to a buffer where, yeah, maximum number of characters. The C string that contains the format string, same as a printf. Let me follow that up. So percent %d is signed decimal integer. It's actually going to be an unsigned decimal integer, so I'm going to use u instead. Not that it matters, given the limited size, but unsigned decimal integer is u. And then I want to make sure that I can safely do the right closing bracket and the null termination character in the string. I'm just not super familiar with doing things this way, so I gotta check myself. Kind of looks like this is all I need, because all of this is within a format specifier. None of them is. Yeah, okay, cool. So that's probably correct. And that's gonna have to be good enough to tally test it. So at this point, what we've done is we've got, for every uniform, we have gathered the number of elements within that uniform. So if it's an array, it's going to be more than one. If it's not an array, it's going to be just one. If it is an array, then we go through and modify the contents of the outstream buffer, which presently has the name of the uniform with the square bracket 0 square bracket, and we are replacing the 0 right square bracket with the number of the thing that we're in. So now we can call GL get uniform location upon it, and this will return the location of that uniform. So now we can do something with it, and I haven't decided how to handle it quite yet. Presently, we're storing a uniform location for. You look up the shader, the hash name of the shader. That gives you another map, and then in there you look up using the variant combination. So all the keywords that form the variant of the shader that you're using. You plug that in, and then you plug in the hash name of the uniform that you're looking at. So I could go a couple of directions with this. The first would be that I would just do what I've been doing before, which is that I enforce the lookup by the hash name, including the element name, the square braces part, within the hash name. I'm presently thinking that that's not what I want to do. I am thinking that I want to actually go ahead and add an additional selector in the internal memory for that. And then when you go to look up the variant, you tell it the index that you want. Or sorry, when you go to look up, not the variant, look up the UBO. So when you go to bind the texture, you pass it the texture handle, and then you pass it the name of the uniform. So in this case, texture slots, and then in the space of an additional parameter, you pass it the index into it. And that index can default to 0, and the result would be that it would look up texture slots at 0. I kind of like that, actually. So what this means, though, is that I need to strip away the square braces on the first element. So this needs to go in an else statement. And then I need to put a slightly different version in here. So what this is saying is that if this is not an array, then I don't bother stripping out the square braces part. It just is stored as is because it doesn't have square braces. And then in here, I need to strip out the square braces. So that's going to be done by using get uniform location using the string out buffer. I think actually I'll want to do this last after looping through all the indices, because what I can do is I can do OGL string out buffer. At insertion pause. I don't know why I can't spell friggin' anything. Insertion pause. -1. So the character before the number 0. I can just set that equal to the null termination character. So that'll give me a null terminated string that ends immediately, ends before the square brace, and then this will be this will handle storing the uniform location for the initial element. Which actually means I can do this out here. Because this will either be the shortened one, or the longer one. But when I go to store the, okay, yeah, I'm starting to realize a problem. Whenever I go to store the elements for each consecutive one, I need to have the string null terminated anyway. So let me undo all this. And what I'll do is I'll put this back up top. Okay. And then here, once we've gotten the before we get the location of the original, we need to strip off the other. So actually this does need to go in here. Or to be more correct, it needs to go after we do the stripping. But I need to do this for everyone. I'm getting my brain's going in circles. So what I need to do is, before I get into the loop, I need to hash the name, the stripped name. So let me move this down below for now, because I know that it has to happen for each one of these. I'll do the sampler uniform types hn. Okay, so first we are storing the type. Let me go to the, okay, so we got types and locations. I need to add an additional level to this. So I think I'm going to do this with a vector. So the last element on these is going to be an index aligned vector. So what I'll do is I'll do std vector. And I know this is adding onto the heap, but whatever. This is just a safe way to store all this stuff. And then I will push back in the places where I would otherwise set it equal. But I'll do that. I'll do that here first, and then I'll worry about the other later. So now sampler uniform types, I can do an index aligned lookup for the element number. Okay. And then I need to either strip the last character or not, depending on whether it's an array type or not. I mean, there is the chance in JLSL that somebody would do this, but I don't see why on earth they would. So we've got in the insertion position, so the length -2. We would then set the, we would then need to get the hash. So what I'll do is I'll do oh, and now I'm realizing that I need to do the hash up here as well. So this actually needs to be later. Oh, and because I have the name length looked up from getActiveUniformName, I don't actually need to do insertion pause anymore. I don't need to do, or that is, insertion pause doesn't have to be looked up using strlen. I actually have the name length right here. So what I would do is I would do ist insertion pause equals name length -2. And then this will have to be handled separately for whether it is an array or if it's not. Actually, I don't even need to allocate another variable for that. I can just use name length as the reference. Okay, so we've got the name length, we've got the string containing the name. If the array size is greater than 1, then what we'll do is null terminate and then hash it. Or I can just hash it now. So we'll do hash name. Except for, so I allocate it up there and then I get uniform name hash equals hash name OGL name length, and now we'll do name length -3. So it's, yeah, so getting rid of the last 3 characters would get rid of the square brace, the 0, and the next square brace. And then down here, we would just do the hash like that. And we would put the uniform name hash in this spot. And we would push back the first one. But now that I'm looking at this, I'm realizing that this one doesn't actually have to be a vector. This one can just be the type, because everything in the array will be the same type. I only need sampler uniform locations to be a vector because that's the only one of these that will differ depending on which one we're looking at. So the types is no longer pushed back. It's the way that it originally was. We just said it's equal to OGL uniform types. And this can actually be moved outside of this if statement now, because either way, we've got the correct hash, the uniform name hash. Okay, good. All right, we're making some progress finally. Uniform name hash, OGL uniform array sizes. Okay, good. Now that we've done that, we need to go ahead and do the modification and get the uniform locations for each of these. So first I need to get the uniform location for the first element. And I'm going to need to put a version of this in both the isArray and notArray branches. So I'm setting the uniform location for the first yeah, I'm setting the uniform location for the first element using the uniform name hash without the 0, because apparently that's legal from what I saw in the uniform block name or the program introspection. Do I have too many? No, I've got the right number of braces. GL get uniform location. I'm not sure what this is complaining about. But the more that I look at it, the more I'm realizing I actually don't need this call. Because the way that I've structured it now, I can actually go ahead and start at 0 here. In insertion pause, instead of using that, I would use name length -3. Okay, so to review, we have identified that the uniform type is a sampler type. We get its name. If the size of the array is greater than 1, then we do a get array. Oh, I haven't done that yet. So first thing I'm doing is that I'm going through all of the array elements. We do a loop for array uniform sizes I, and then changing the termination of the name string to include the correct accessor, square brace followed by the correct index. And then I call get uniform location, which stores it in nowhere. I need to store that. And get uniform location will be stored in sampler uniform locations. At the hash name, shader name, the variant lookup key, with the uniform name hash dot pushback. Good, okay. So that will make it so that we can access the location with the index aligned to the element. Okay, good. And then down here, sampler uniform locations, very key. This needs to be dot pushback as well. Okay. Well, it was okay, and I've got a problem. And I think this is going to be a little bit harder to straighten out, but the problem appears to be the use of my EPGL error wrapper. So around every OpenGL call, I do EPGL. That expands into this macro, which does a GL get error. And it's apparently thinking that when I insert all of this into the line, that is missing a closing parenthesis. And so it is. because what's doing is it's inserting a code, a semicolon next to the code that's in the braces, which means that this whole thing comes out as a sequence of statements. So yeah, I'm actually, if I'm going to do pushback, I can't do EBGL around it. What I'll need to do is I'll need to do this call and then push its results, store its results into a variable. And then push results into the pushback. So that should be a GL int. Right? GL int. Okay. And that seems to resolve this problem with the wrapper. I guess I just can't use the wrapper within a parameter when I'm doing something like this. So bam. Okay. Cool. And I can actually rename this to loc. Oh, that's not what I wanted to name it. So like loc for location. And I think that's it. And because I'm hashing the uniform name before I do all the editing of OGL string buffer, their string out buffer, this call can exist outside. Cool. Okay, so all that work, after doing all that, now we finally got it so that we're correctly, when we go to introspect, and the sampler happens to be a sampler array, that we are storing that in a fashion where we can look up the location of each sampler array, or sampler element in the sampler array. Now I just got to work on the API for binding to textures. Okay, so presently I take the texture handle and I take the uniform name. Now I'm going to accept an optional argument, unsigned int index equals 0 by default. That argument is going to point to which element in the sampler array we want to bind to. So we'll use that location. By default, we'll use the 0. So let me document it real quick. Param element of the array to bind to. And now let's go back to the definition, add this parameter, and use it. Cool. So now we've got an index. And so basically we call GL bind texture. There's some texture slot handling in here where we make sure that we've not bound to too many texture units in OpenGL, so we can fit them in. There's 32 texture slots allowed on my computer. On my Mac, it's 16, I think. But most PCs and modern computers will be at least 32, depending on the graphics card. Okay, and then this is where we are using the I'm a little confused. I don't actually invoke the uniform for a while. So this is specifically just binding the texture to a slot, which is not the same thing as one of the locations. Then we check that the sampler exists within the shader, and this is still a valid check. Ensure that the sampler type and texture match. Active shader name, uniform, sampler type needed for texture. Yeah. And then update sampler uniform if needed. Current sampler assignment. If needed, meaning that it actually checks to see whether that sampler uniform is still set to the correct texture, which is, probably not needed in many cases, but if you're consistently every frame is consistently got the same slot numbers for the same textures, then this can speed things up. So if you have low numbers of textures, this can be a speed boost. So this is the spot, sampler uniform locations. This needs to be index. And prior to that call, right? It needs to be index. Why are you not complaining? Sampler uniform locations. Yeah, it's a vector. Oh, so I need to call .at. Right? I can do index lookup on std vectors, I'm sure I can. The operator access element. So sampler uniform locations. It's a map of a map of a map. Okay, this might just be Visual Studio being stupid. because it seems to think, when I mouse over it, it seems to think that it is a hash name, or that it's simply an int. It's associated with an int. But if I control click on it to go to its location, it is now an STD vector of glint. So it's wrong in this case. I'm not the one that's wrong. It's just give it a minute to figure out that it's not actually wrong. Wait for IntelliSense to catch up. So before I do that, though, I do need to do the check to confirm that index is less than the size. So if I do if dot size is, or if index is less than size. It is very peculiar that it's not caught up yet. It makes me wonder if there's something else wrong in the file above that's causing it to think that this is a map of hash named int. Oh, that's why. Okay. I actually, in order to, in an effort to keep OpenGL code out of my system code, I am, or system headers, I am doing an extern here referencing the same thing. So I actually need to update this. And then that should work better. It's weird that it was referring to the oh no, I was in textures.cpp. Okay, never mind. So yeah, I was referring to the extern one and not the original. Okay, I got it. All right, I'm picking up what you're putting down. All right, cool. So we do the check to see whether index is less than the size. If it is, then we can do this. Else, we've got a problem. EP error. And I'll do the index in the warning. So it'll be hn2 string active. Well, I suppose I should do a shader. Shader name, and then I'll do hn to stir uniform, and then index. Except for that's out of order. So it'll say sampler uniform, uniform, and then the braces, index, and then the name of the whatever does not exist. All right, and then I can do return, even though it's going to return anyway. I'll just make it explicit. And cool. Now the API has been updated, so I can provide a texture index. or a uniform index. So if I'm working it within an array. So let's head to Renderer 2D. Go to Bind Texture. And now I don't have to do this massive case break thing anymore. I can actually just do texture slots and then pass the index j. So text slot at j. J is the index of the text slot. Yeah, I guess I'll press F5 and see what I broke. If I broke anything, probably broke something, because that's how this stuff works. Apparently compiled. Surely I've got another bind texture call somewhere. Maybe not. Maybe I commented all that stuff out. Okay, so we got something, but they're all the same sprite again, which isn't great. But I'm also getting no warnings either. So I'm going into the third texture bind. Let me take and convert the uniform to name. Yeah, that seems to be correct. So this is the hash of texture slots. Index is 2. Texture handle is 3. It's correctly identified that we need to bind it to a slot. It's correctly identified that it needs to be bound as a texture 2D, so it's binding texture 3 to slot texture 2D, I guess. I guess the slot is bound up here, active texture 0 plus the max 1, yeah. And that's the problem there. Current sampler assignment. The problem is that this is still associating just a single one hash name with a value. This needs to be an STD vector as well. because now there might be more than one sampler associated with a hash name. The types can still be hash name because every type is going to be the same. But now I need to find all uses of this and fix that. Okay. Getting close. I'm expecting it to probably be off stream in 30 minutes with a working batch renderer going, if not a great one. So what I just did here is I had to make sure that current sampler assignment has an element to look up at the index we were looking for. The index might be 0, which is a valid index. So what I'll do is I'll do pushback -1, which is going to be always an invalid value. And then we'll say if the current sampler assignment for this index is not equal to the current slot of the texture, which can only be 0 through, n textures, then we will set it. Provided, and we have this additional check to say sampler uniform locations whether the index is less than the size of sampler uniform locations, which is set in the other file when we do the parsing. So actually, this check should go on the outside of both of these. So that way we're doing the check to see whether we even have a uniform of that kind whether it exists. And then if it does exist, then we will ensure that we have an index in current sampler assignment, and then check it. Okay, cool. F5. Oh, we got an assertion. Great, what do we got? Vector subscript out of range. Let's take a look at the stack. If current sampler assignment, add active shader name, active shader options, uniform, index. Is not equal to current slot of texture at texture. Size 0. So we have all the sampler uniform locations initialized to -1 correctly because they're not currently bound to a slot in OpenGL texture slot, not my shader slot. I don't get it. Maybe I misunderstood the error. Vector subscript out of range, indicating that we're accessing an element that doesn't exist. But as I have inspected on the stack trace, the element does exist for everything in here. So so that element definitely exists. Let me stop for a moment. I will throw a breakpoint. So there's an element at active shader name. And there's a sub element accepting a size 0 container for the key. And then there's a sub element with uniform as its key. But its size is 0. Oh, I see. So this while loop that I had placed above with the intention of making sure that there was enough elements to access, it should be, I said if while index is less than the size, it actually should be less than or equal to the size. Because if it's equal to the size, then the index is an invalid index and you need to increase the, so, all right. Okay, no crash this time. But it is hanging. So why are we hanging? We're in an infinite loop. Okay, what did I screw up? So index is less than or equal to create sampler assignment at the active shader name at the size 0 shader options at the uniform its size is growing crazy large, so we're already at 6 million. So it's not so I need to have while index is greater than or equal to the size. I not sure how I screwed that up, but I did. So it was, if it's, I was assuming less than, it should have been the other way around. All right, what do we got? Okay, well, no crashes, no warnings, but I'm still not seeing the right texture. So something is still wrong. I'm gonna do a quick if def 0 or if 0 else. And if to quickly switch between these two modes. I'm going to test this again by printing out the index once more. Confirm that we are still doing the correct, so we still are doing, passing the correct texture indices to these. They're just not getting the right texture for some binding reason. And setting it back to 1 should put us to, and now we've got the link for all three when it should be different for each one. Oh man, I'm getting really frustrated with this. Okay, so I was just checking here to make sure that we did the texture right. I'm going to change the order of the textures that we load. Really shouldn't make a difference, but yeah. And so now they're all using the first sprite instead of their respective sprites. The first sprite in the list was Madeline. Let's go into the code that we use for setting the sprite. So putting a breakpoint at the parsing code for loading the texture. Getting different indices every time, which indicates that they're actually loading separately from the texture loader. Maybe something wrong with how I'm doing binding. Back when I originally wrote this code, I had successfully tested binding a bunch of textures at the same time. So I know that it's a pretty solid code, but maybe the change that I made with the index, maybe that is causing more problems than I thought. Let's go through this step by step with the debugger. Let's turn off that breakpoint. Continue. All right. So we are looking at bind texture for the first texture, which we already know that the first texture works because they're all Madeline for some reason. Here we are with texture 2. Let's get the uniform name. Copy, watch 1, and I'll do hn to string and unhash the uniform name. So the uniform name is coming in as texture slots, which is what I'd expect. Index is coming in as 1, which is what I'd expect. 1 being the index into this uniform sampler 2D. texture reference count path of, yeah. The texture reference count for texture should be so path of texture, yeah, 155601. It's 1. Yeah, so it does have a reference count already, indicating that we've loaded it successfully, which is what I'd expected. Current slot of texture for number 2 is -1, meaning that it's not currently bound to a slot. And this is the logic that actually picks an available slot. Last bound texture slot is 0 because we just assigned the texture handle 1 to it. This texture slot uses draw I over next texture slots. We actually will just like go through every frame. We will go through the list until we find that we've bound too many per draw call. That way, if we've bound something in the previous draw call that we could use in a subsequent draw call, we just keep using it and we don't bind it again. Okay, we are successfully calling bind texture for the texture handle. So apparently that part is working. Problem must be in here. Current slot of texture. So we're doing texture in slot 1. What's going on with texture in slot? So texture in slot is being assigned to current slot of texture 2 should be equal to 1. this all seems to check out. Hang on, that's a, oh, that's actually correct. Never mind. I think I've identified a problem. Yeah, it took just a lot of deep thinking about each line, but I think I've identified something. So this is the line of code where we actually tell OpenGL to update a uniform value. So I need the uniform location to do that. When I go in here to sampler uniform locations, looking underneath the active shader name, and then the active shader options, and then the uniform name, we get the array of all of the where all the locations are supposed to be. But they're all -1. So if we pass in this value, it is not actually referring to a valid location. The crazy thing is that the first texture is even working at all, because you'd think, because they're all -1, that the first time we go in here we would be getting the wrong. Maybe it's just defaulting, like doing a default location of 0. And so I'm binding to that location on accident for the first texture I load. That's the only reason I can think of why this would work. But the fact that sampler uniform locations is not got actual numbers in it tells me that I messed up when setting its values. So here we are back in compile shader source. Let me stop debugging. So it sounds like we're pushing back enough values, because there are 16 values in there, and there should be, because there's 16 samplers in that array. But I think the values that we're pushing in there are all -1 somehow. Yeah, so here we go. Location of GL get uniform location program. OGL string out buffer is -1. And if I look up the call get uniform location, I'm willing to bet that a -1, yeah, function returns -1 if name does not correspond to an active uniform variable in program. So I must have messed up the parser somewhere. Yeah, so OGL string buffer says texture slots 0 with a right square bracket. Oh. Okay, yeah, I get it. So what I think has happened is that when I was originally working on this section, I was thinking that I would be keeping the original left square bracket and just appending or changing the number and the right square bracket. What I think would actually happen was I had moved that logic to be higher in the chain, so we are always using this, not just on indexes 1 and up, so even index 0. And so then I am starting the printf from the end -3, and I'm not replacing the square brace. And I need to, because that used to be a null termination character, and yeah, okay. All right. I hope that's it. You know, we'll see, I guess. Let me shift click to make these not work or not break. We'll see if it'll be able to recompile and continue. Yes! Fucking finally. All right, so let's review what we've got here. These sprites are components in the ECS system. They take their position and their scale from the location and scale of the entity that they are connected to. These are loaded in from a data file, and so are their textures, and these are all rendered in a single draw call by use of batching the quads. We transform the locations on the CPU. Okay, great. Yeah, so that sounds like it's working. So what this means is that if I was to fill a scene full of these entities, they wouldn't just be wasting your draw calls. Now, there's obviously quite a bit more work to do. The first and most obvious thing that I need to address is the fact that these textures Sorry, that I just noticed something. What was I saying? Yeah, the first thing I need to address is the fact that these are being drawn all the time, that these sprites, these textures, are rendering even if they're off screen. So the way that I want renderers to work in Enterprise is that each renderer handles its own culling. So I'm going to need to implement an algorithm for selecting only the entities in or only the sprite components that have a chance of being drawn in the view frustum, to get them to skip being put into the list of drawn stuff every frame. God, it's so great to have this working smoothly that I'm just having enjoyed playing around with this just for a little bit. So I need to implement culling, and then after that, I need to start working on some of the goals I have for the GLSL side, because right now this is working in the shader that is specifically designed for rendering in batch. What I need is to be able to do the same thing from a much simpler shader using an include file. So this is the mock-up that I made of what I want to do. So presently when I write this shader, I'm doing all the work. I'm including the sampler 2D array here. I am doing the input for the position, the UV, and the texture ID, and then passing it out. And down here, I am actually dereferencing the sampler in the array using the texture ID and doing the sampler there. What I want to do is I want to wrap those in macros that allow me to compile a version that works in batch and in normal rendering. So if there's a renderer that wants to use the shader in a material, that it doesn't have to do it in batch if it doesn't want to. Like say I'm applying a shader to a particularly complex 3D model, then the renderer that handles the model will want to have the executive decision on whether or not to batch it, which means that there's going to need to be a version of this shader that does batch and the other that does not. So in the mock-up, and this is what I'm going to be pushing to get to with my material system, I'll be able to just like do a header like this, which includes the boilerplate code in such a way that I just include it, and then I use the macros appropriately. So I use like EPB for enterprise batch, use its sampler 2D declaration macro instead of declaring it myself. I would use the helper macro to pass through the sampler to the other side, and then simply use an overloaded texture macro here. And what this would do is it would, in the vertex shader, when you're doing a batch, it would replace this with the vertex attribute in int with the name of the texture, as well as the output needed to pass it on. But then and then handle the rest like you would with the batch shader. But then in the non-batched version, it would simply do a uniform sampler 2D the way that you would if you weren't trying to batch your stuff together. So yeah, that's going to require quite a bit more work on the GLSL part. But yeah, it's important to have a baseline here. I'm like long-term plan, I'm thinking that I'm going to need to get at least a basic text renderer going and then start looking at getting an editor going. Because without an editor to like author level files and author material files and so on, then it's going to be like, yeah, like I don't want to be, I would not want to make a game just like typing in all the position of every single entity, right? You need an editor So I need to get something going, and one of the fundamental things I'll need is the ability to print text. So I need to get a renderer going that can do that. But yeah, this is great strides today. I've got a batch renderer going, if only technically, and then I can use this as a baseline for building a more robust renderer that can use any number of shader files authored by a dev to do cool things like, you know, lighting and, you know, surface normals and, you know, distortion and things like that. Cool. I'm glad this is taken care of. I'm going to do something else now. Have a great night for whoever is watching. Bye.